Okay, so this video is about a cross product. So cross product is the computation of the product of two vectors. Here the vectors must be in the 3D space. So for example, here I give you two vectors A and B. A is A1, A2, A3, and B is B1, B2, B3. So the cross product of A and B is computed based on the determinant of a 3x3 matrix. Okay, the 3x3 matrix is composed of this. The first row is always I, J, K. The second row of the 3x3 matrix is whatever comes first. So the first one of A, you come here, you put the first vector as the second row. So it's A1, A2, A3. The B vector comes as the third row, so it's B1, B2, B3. So if you swap B and A, you'll swap the two rows. Okay. Now it ends up we have to compute the determinant of 3x3 matrix. Okay. If you remember how to compute the determinant of 3x3 matrix, you can use any row and any column, and then reduce the computation of determinant of 3x3 matrix to the computation of 2x2 matrix, a number of these. If I'm using the first one, okay, I'm using the first one to reduce the computation of a 3x3 determinant of 3x3 matrix to 2x2 determinant 2x2 matrices. Okay, so for the first one is something times I, right? We know that something times I. Or we can write this way: is I time is always times -1, and this the power to the -1 is determined by the number of column, number of rows this I is sitting on. So right now it's sitting as the first row and the first column, so this is 1 plus 1. Then the next step is we have a 2x2 matrix, and we compute the determinant of that. This 2x2 matrix is by deleting the rows and the column that this I is sitting on. Because it's sitting on the first row, so delete the first row. Because sitting on the first column, so delete the first column. So we end up having A2, A3, and B2 and B3. Okay. Now we move to the second entry, which is J. Also we time -1. This is because it's sitting on the first row and the second column, so it is 1 plus 2. So this is the number of column and this number of rows. All the reverse way is fine. And again, here we still have to construct a 2x2 matrix. Again, the rule is to delete the rows and columns that this J is sitting on. So we should delete the first row and the second column. So I have A1, A3, B1, B3. Okay, and so on and so forth to the last one. K is -1. This is 1 plus 3 because the first row and the third column. And again, I'm going to delete the rows and columns that this K vector is sitting on because it's sitting on the first row and last column. So I delete the first row and last column. So I end up having A1, A2, B1, and B2. Okay, now you know how to compute this, because this becomes I, because -1 to the squared is 1, time the determinant 2x2 matrix is just a product of the diagonal entries A2, B3 minus the product of the off diagonal entries, which is B2, A3. The second one will be minus, we can do this plus J. Okay, this becomes -1 time. This is again the 2x2 determinant 2x2 matrix is A1, B3 minus B1, A3 plus K. -1 to the fourth will be still property 1, and your time the determinant 2x2 matrix is A1, B2 minus A2, B1. Okay, so this is also a vector. You can write this form as a vector, which is A2, B3 minus B2, A3. So you put whatever coefficient for your i's as the first one, and whatever coefficient for j as the second one, similar for whatever coefficient for k, put as the third one. The second one, because there's a negative sign here, so I'm going to swap out of this two. So it's B1 A3 minus A1 B3 The last one was a1b2 minus a2b1. So that's the definition of cross product. So let's go over one simple example. Okay, again here this vector must be three-dimensional one. So this is 1, 2, 3 for example. B vector is 3, 2, 1 for example. Let's compute the cross product. According to what I mentioned before, so it is the determinant of a 3 by 3 matrix is I, J, K, right? So the first row is always I, J, K, and second row is determined by the A vector. It's 1, 2, 3. Okay, third row is determined by the B vector, which is 3, 2, 1. So I compute as according to the first row as I did in the definition. I use the first row. Okay. So end of having is I times -1. So if I delete the first row and the first column, as I did explain earlier, delete whatever rows and columns is I is sitting on. So first row, first columns have 2, 3, 2, and 1, plus following the same rules, J -1. So this has to be 1 plus 1. 1 plus 2. I have delete the first row and the second column. So I have 1, 3, 3, and 1, plus K -1, 1 plus 3. Okay, because it's sitting on the first row and the third column. And delete first row and third column, so I have 1, 2, 3, and 2. Okay. So by computing, this one will be just 1. Okay, this one will be just 1. Okay, and this guy will be just -1. Okay. So have 1, we can just ignore that. So the determinant 2 by 2 matrix is I, can use black color, I times 2 times 1 minus 3 times 2. Okay, this is plus J, right? This is -1 times 1 times 1 minus 3 times 3, and plus K. This is also property of 1 times 1 times 2 minus 3 times 2. So which gives us 2 minus 6 is -4 times I, plus this become plus because negative sign, this is -8, so it's 8J. This is 2 minus 6 is minus 4K. So this gives us is -4, 8, -4. Okay, I hope this is a little clear to explain what the cross product is trying to do. Okay.